Welcome back to my YouTube channel PGK Kadam Academy. Dear friend, this is the vibration measurement video series. We are going to learn the acceleration pickup and also going to see the application of this acceleration measuring instrument as an engine knocking sensor. Dear friend, various parameters are there we can measure for the measuring instrument for the vibration. The displacement amplitude measuring instrument is there, vibrometer, or velocity measuring instrument, velometer is there, or acceleration measuring instrument, accelerometer is there, and frequency measuring instruments are there. You can watch the video separate on this every parameter. Accelerometer, acceleration pickup used to measure the acceleration of vibrating body. It's an instrument that measures the acceleration of the body, and it's more used for the vibration measurement, and it's a seismic instrument. It's also used for the earthquake measurements. Recording the earthquakes, it's also used. You can see the figure here. The piezoelectric element is there, and the triangular piezoelectric element is there, and the triangular post is there, and preloading ring is there, and seismic mass is there. This one is the seismic mass. This is the actual diagram. But when we go in detail principle of this working, how it will work, accelerometer, acceleration pickup, the equation we can derive from this seismic instrument. The steady state relative amplitude we can write like Z is equal to R square Y upon under root of inside the bracket 1 minus R square bracket square plus inside the bracket 2 theta R square. What is R? R the ratio, frequency ratio we can call omega upon omega n. Zeta, damping coefficient, that C is the damping factor, and this 2 m omega n. What is omega n? Omega n is the frequency of that instrument, and this frequency ratio omega by omega n very large, or we can say the omega n natural frequency of this small is compared to omega of the body is very small. That means what? It will give the value that omega by omega n is square into y approximately z, that relative amplitude is equal to like this. Then when omega n is constant for the given instrument, then we can write the z is equal to y omega square, and ultimately we can say get the values from this instrument that relative amplitude is approximately equal to the acceleration of that body when it is vibrating. So friend, that means what? The relative amplitude is proportionate with the acceleration of the body which is in vibration. So that this you will get the values on the in case of the through our voltmeter or ammeter, current voltmeter is there, or through our display we'll get the values of this relative amplitude directly. From this accelerometer records, we can find out the velocity also, displacement, by obtaining the integration. These two types of accelerometer are there commonly used, compression type and shear type. So this mostly piezoelectric transducer is compression type is used for the accelerometer. So we are going to learn this piezoelectric accelerometer is construction, principle of working, and the how the technique to find the velocity or the acceleration from this equipment, and where it is used, this equipment. Dear friend, here already we have studied the condition for using the seismometer or acceleration measurement, that it has very high natural frequency omega n, and it should generate output signal proportional to the relative acceleration of the body. This piezoelectric accelerometer has the natural frequency of the instrument should be very large as compared to frequency of vibrating body. So this is possible when there is a mass m, seismic mass is there m, and that mass is small, and the spring has very large stiffness K. Spring is there, You can see here crystal element is there, a preloaded spring is there, very large stiffness of K, this mass M is there, seismic mass, this crystal element, that is piezoelectric crystal is there, and this is the base. It is attached with the mounting a vibrating body, and vibration will be done in this direction. It is shown in figure. Okay. So friend, what will happen? This piezoelectric crystal accelerometer, which is used to measure the acceleration of the vibrating body with higher frequency. When there is a higher frequency, it is used. So friend, this piezoelectric crystal is capable of generating measurable signal of the small deformation also. The signal is very weak. The amplifier is used to amplify the signals. So friends, these are the actual typical piezoelectric accelerometer used in industry. You can see here the cut section diagram, and this is the actual piezoelectric accelerometer. Piezoelectric accelerometer is self-generating, so it is passive type vibration measuring instrument, so that it does not need a power supply. It has very wide frequency and dynamic ranges with the good linearity throughout the ranges. The engine knock sensor is one of the piezoelectric accelerometer application. You can see here, this is the applied on this engine head. This is the one of the company who manufactured this accelerometer, piezoelectric accelerometer. Plain, the knocking occurs when the air-fuel mixture, when self ignites prematurely. That knocking we can observe, and we can stop the knocking. So friend, what will happen? Why knocking occur in engine? That will also, you have the question in your mind. That knocking occurs when fuel burns unevenly in your engine cylinders. So when cylinders have correct balance of air and fuel, the fuel will burn in small regulated pocket instead of all at once. The fuel will burn small, but all fuel will burn. When the correct balance is there, due to this it will burn. Then knocking will occur, and the sensors are used in this one. So this piston, the piston inside the cylinder compresses the air-fuel mixture inside the combustion chamber. A spark plug, you can see here spark plug. This is the spark plug. The spark plug placed at the top of the cylinder to initiate the combustion. And in uncontrollable situation, when air-fuel mixture is balanced, that self-ignition takes place without the initiation of spark plug. Here you can observe the uncontrollable solution. Self-ignition takes place here, and after that, meanwhile, the spark plug also ignites the air-fuel mixture from another point, and thus the inside this cycling, the 2 points are ignited. You can observe here red mark, 1 point, and another 2 points are there ignited, and the flames from these 2 points collide with each other. This activity happen within fractions of a second, and this detonation creates vibration and sound. This detonation will create vibration and sound in the engine, and this is called as engine knocking. So what will happen? What are the typical damages are there resulting from the conventional? You can observe here the piston melts. It will get, due to high temperature, it will get melts. The cylinder bore scuffing will be occur. Spark ceramic fragmented, or the gasket leakage will be there, or cylinder piston head erosion will be there, or exhaust valve melt, or the possibility of the piston ring land crank will be damaged. So these are some damage figures. It identified a high frequency engine vibration and characteristics of knocking, and transmit the vibration to the current signal to the engine control in ECU unit. What will happen due to the high frequency? This type of the are used. The piezoelectric sensors are used as a engine knock sensors that will transmit the vibration to current signal, and that signal is given to the ECU. What is the ECU? engine control unit. What is the ECU will do? ECU compare the delay, compare the original stored the what is the vibration is required, and if vibration is more, it will compare and then it will delay the ignition timing until the noise level return to the normal. So friends, here knocking sensor can reduce what? The fuel consumption, and 9% fuel saving will be there, and increase the torque up to 5% torque will increase due to this knock sensor. And vibration testing, monitoring, other application you can see the shock pulse monitoring and motor bearings for the purpose of the motor bearings in inertial navigations for airplanes and the spacecrafts, drones and unmanned air vehicles, impact testing, and the research development. These are the few applications. Again, we can see here the anti-shock inspection in nuclear power plant. This measuring vibration pollution in railway, road, vehicles, and civil engineering. The geological survey, the seismometer, and the vibration control, and the safety reliability in airbags, traction control, aviation, or driving these experienced vehicle. And we can see the equipment check and the device protection interlock system, ultra precision processing, semiconductor exposure line. Here is the high frequency is there, and the frequency is low, and here acceleration is very high, and these are the where is the acceleration is very low. So we can see here piezoelectric acceleration pickup we can use for the high frequency. This is the zone for the piezoelectric acceleration. So these are the 4 types of the acceleration: displacement, the pickup, servo pickup. So friends, this is the detailed acceleration pickup and its application. If you are not subscribed my channel, please subscribe, share, and like the videos. Thank you very much.